Okay, let me go ahead and get my screen up. Okay, I believe I'm coming through. Are you able to see my screen? Does it have a presentation? Yeah? Okay, great. All right. Today, the focus, I think, of the conversation is really understanding the unique layers of technology that are built on top of, satellites. We often think about going to space, the incredible rockets that, put hardware up on orbit. And from a commercial standpoint, the primary reason that we do that is to acquire data that comes back down here to Earth. And so how does that get used? How does that end up in our smartphones and literally every single app on our smartphone using GPS? So that's the story I want to try to help unpack and think about how space affects our everyday lives. So we'll sort of break this into two sections. One is understanding what that technology stack looks like, really from learning from the history of GPS. Thinking about what the future looks like, and then looking at the career landscape. I think typically folks have an expectation of what the traditional space infrastructure looks like. So we'll break down what are opportunities to get involved, and how you could start building a career. The first thing I wanted to start out with, if you haven't had a chance to read this piece, I would highly recommend it. It's called the GPS Playbook. We co-authored this with Silicon Valley Bank, and it goes into a deep dive about how GPS became really the world's first and only global utility, and how it powers, almost every major industry on the planet today, and is really a critical piece of infrastructure. It's a fascinating history, and we talk about some pretty incredible future applications that affect autonomous navigation and creating a mirror world for three-dimensional mapping, and some really exciting themes that we're excited about investing in. So I'll borrow from a couple slides in that presentation. The first is unpacking the history of GPS and the critical milestones that happened over a period of time that help us understand the layers of technology in the stack. So starting back in the late 70s, Navstar 1 was launched. It was largely a military satellite with a pretty much singular focus: precision-guided warfare. It slowly started to open up to commercial use cases in the 80s with companies like Trimble, Magellan, TomTom, starting to use basic mapping. When I was a kid, we had a very large device that was mounted in the car, and it would help guide you from point A to point B. It's hard to think of what the world was like before, like Google Maps or Waze or things like that. But it was this huge piece of hardware that existed actually on your dashboard. And so that was sort of the early adoption of GPS and how we started to commercialize it. And some of these companies became multi-billion-dollar companies, created tremendous value in agriculture and navigation and logistics and critical infrastructure here on Earth. So in 2000, under the Clinton administration, they ended what was called selective availability. So that actually unlocked high precision location awareness that used to only be available to the military. So commercial use cases started to be able to build on that higher precision location. And then 1 year later, Qualcomm launched a chip called GPS-1 that allowed mobile phones to be able to act as a GPS receiver. And pretty much overnight, you went from maybe tens of thousands of devices connected to GPS to hundreds of thousands of mobile devices connected to GPS. And that started to create an infrastructure where more and more people started to leverage location awareness. And so you started to get companies like Yelp and Google Maps to develop, new use cases that could help you understand where you're at in space and time. The real shift here happened in 2008. You can go back and actually look at the launch of the iPhone 3G. Steve Jobs is up on stage. He's introducing, critical new steps, and he shows a map with a blue location dot on it. And he said, the iPhone is now going to have GPS capabilities, and he thinks this is going to unlock a whole new wave of applications that get built. And so with that launch, they also launched the App Store that made it super easy for developers to start leveraging satellite signals in their applications. And that was really the birth of what we know as location-based services. Quickly after that, you got companies like Uber, Lyft, Turo, Foursquare, Tinder, Postmates, Root, and my favorite, like the absolute craziest sort of conclusion of this whole scenario was Pokemon Go. Like the military experts that were thinking about precision guided warfare back in the 1970s could have never envisioned a world where, collaboratively we're playing an augmented reality video game out in the physical world. And I think that's a perfect example of what happens when space technology becomes ubiquitous in our everyday lives, and we just get to experiment with it and create and build on it. And so I walk through this history because it tells us it teaches us a really important lesson. There is a unique technology stack that gets built on space, infrastructure. We start out with the satellites that produce a signal or help provide us a unique perspective of the world. We get a sort of middleware layer that helps distribute the signal to make it accessible and ubiquitous and interpretable in our everyday lives. And then with that, it allows software developers or software engineers to not really have any knowledge of the satellites at all. They don't need that. They're essentially just working with data, working with insights to build powerful new tools in our everyday lives. And through that technology stack, through the abstraction of the technology from hardware into code, you're able to create innovation. And so we are at a time where that evolution of GPS, it's not over. It's actually just at a next wave of its evolution. So we have recently launched GPS 3, which provides higher precision location awareness. And we're at a point now where many of the industries and next generation technologies require much higher fidelity of location awareness. So this includes companies that are building next generation augmented reality capabilities as we start to digitize the physical world. Very precise awareness of where you're at and where things are and where advertising and experience could be is going to be really based on how we know where we're at in space and time. How do robotics, autonomous robots navigate our street corners and navigate our buildings and be able to actually connect with us in our everyday world? It's ultra precise awareness of where they're at that will allow them to be able to do that. And that's going to require a whole new level of mapping and precision awareness. The other two areas that I think often get overlooked, but have been, staples of space technology for, 30, 40 years. So the first I'll touch on, which often gets the most sort of hype in the media, is communications. So we often don't think that, communications is really that important or that present in our everyday lives, but 24-hour news, satellite TV, satellite radio, the ability to get internet in remote places, satellites are already affecting, our media and communication infrastructure everywhere. What's happening now, particularly with Starlink, OneWeb, Project Kuiper, is the convergence of our internet infrastructure moving from fiber optic lines, which are inherently limited to where they can go, to global, ubiquitous, high-speed connectivity anywhere and everywhere. I mean, this is a fundamental shift of the internet converging with the space industry. And it's massive. That's why, some of the biggest technology names are building ground station capabilities, launching satellites, why Facebook was experimenting with high altitude balloons and trying to launch, platforms. This is how the internet continues to grow and how the internet moves off of our screens and into a physical world in our everyday lives. And a critical component of that is going to be in geospatial intelligence. How do we actually know where we are, what's happening, how things are changing over time? What are the different layers of imagery that we can utilize to conduct business, to coordinate our lives, to monitor our precious resources? And this is where geospatial intelligence is incredibly important, and where innovation in the infrastructure has allowed a ton of new companies to launch new services. So companies like Planet and their doves, super doves, companies like ICEYE that are using synthetic aperture radar. But those are only two of the signals that we're capturing, optical and SAR. There's hyperspectral, multispectral, RF, radio frequency positioning, there's radio occultation, there's infrared. So there is many, many, many new instruments that are capturing very powerful data sets, far more rich and potentially powerful than what we have seen in GPS. And the combination of that, knowing how big GPS has been and what it created, and this whole new open sort of white space for innovation, makes it an incredibly exciting time to look for opportunities at the intersection of space and technology. So I want to give you a sense of, so we talked about those three layers. Every quarter, we put out a report that looks at the flow of investment into this theme to really help us understand what's happening, what the opportunities are, the scale, who's involved, and so on. And so right here, this is our third quarter data. This is looking at 2009, when sort of, this opened up to really a lot of commercial and entrepreneurial activity. The total investment to date has been 166 billion. You're like, okay, well, that sounds like a lot of money. How big is that? Well, all of the investment in autonomous navigation, from Waymo to all of the other companies, is 200 billion. If you think about how big virtual reality is, virtual reality, that entire industry is only $30 billion of equity investment. So this is massive. This is on the scale of literally how do we create our entire new sort of, autonomous navigation infrastructure. And when you look at this, the critical infrastructure layers are, about maybe 1/5 of the activity. And a lot of the unique applications that get built on top of it, that's where a lot of the money goes. There is that distribution layer, which is, it really lives at the intersection of processing signals, processing data, using algorithms to interpret spatial, information, and then distribute and disseminate it. And so it's a critical layer, but it's a small layer. And so the competition of what's happening to build and leverage the space stack is really being led by the United States, and then very closely after that, China. Nobody else even comes close to those two countries utilizing this information for their industries. So you can understand why this might now start to be a little bit contentious from a political standpoint. There's really only two players that matter in this game. I want to dig into the infrastructure, what you think of traditionally as sort of rockets and satellites, and answer a couple important questions here. So a lot of students come to me and they're super excited about, people building space stations and, going to the moon and thinking about opportunities beyond low Earth orbit. So right here is the flow of capital from a venture standpoint. The two largest areas very clearly are launch and satellites. Um, Everything out here is sort of these emerging industries that would be an on-orbit economy. And you can see, there isn't commercial investment happening here. And that's because the market doesn't currently exist. The government pays for some small activity here, but until there is some sort of commercial activity, this stuff is mostly for government and scientific purposes. So when we talk about space from a commercial perspective, a lot of the money has flown into launch to reduce launch costs and make it easier to put objects on orbit. And then primarily these satellites that are collecting data that come back down here to Earth to help us, do our activities. So I think that might help address a common misconception. Oftentimes people feel a need to defend investing in space or why we go to space. And they say, why would we ever, neglect the activities that are happening here on Earth? I mean, from a commercial perspective, the primary reason we go to space is for the benefit of Earth, how we navigate, how we interpret, how we communicate on a global scale. The one thing I will mention here is Earth observation satellites, those geospatial intelligence satellites, they make up a pretty small portion of investment. It's mostly communication satellites. But from an activity standpoint, there's a lot more activity happening here. This is where you're seeing, it's pretty easy for folks to put up some type of sensor on one or two satellites, capture new data, and see if they can sell it in a productive way. So there's a lot of experimentation happening there and within components, people building new propulsion systems, new satellite buses, and things like that. So now I'll dig into the applications, and we're not going to get too granular here. We try to keep it focused on sort of the core infrastructure verticals. Where do those applications exist, and where is the majority of the investment going? And so what's most important to note is almost all of that, $100+ billion that's going into, space, applications, it's almost all location-based services. And that's important because when we talk about the growth potential of space and how it could become a $1 trillion investment opportunity, it's not about asteroid mining. It's actually about creating the applications that leverage the communication infrastructure and the Earth observation infrastructure that have gone up over the last 10 years. We think that the amount of investment in the applications in these two sections will be as large as location-based services has been. So there is tremendous opportunity here. I mean, I can't understate this. There is probably no other bigger opportunity to start understanding this data, utilizing it, and radically reshaping almost every industry. So that was the high-level overview, and hopefully that challenged maybe a few assumptions that you have about space. I hope that you sort of take away that space is the reason we go to space from a commercial perspective is to collect data, and there is a tremendous opportunity to use that data right now back here on Earth. So I want to look at, the more traditional sort of aerospace infrastructure career opportunities and give you a little bit of insight and unpack that a little bit. Typically, that's sort of the hardest for why most people are excited about these conversations and help you understand it. So, in 2019, we looked at, around 8,000 jobs and understood sort of where those opportunities were at, what stage they were at, and how does that compare, the major sort of established players out there, the Lockheed Martins, the Boeings, companies like that, versus the new sort of entrepreneurial upstarts. And what you see, is these established players, very few of them specialize in like one specific area or technology. they actually end up, most of them are conglomerates. They do a lot of different things. It's all bundled together, and space is sort of one vertical. And so that's what you see here. And actually, that's part of the disruption that's happening is, being very specialized and being very good at one thing can actually give you a competitive edge. And that's where the entrepreneurial approach is showing up. So when we look at those jobs, the vast majority of those are showing up in, in the launch sector. And heavy launch and small launch, there are a ton of opportunity. If there is one segment that has received an unrealistic amount of capital, it is small launch. It's incredible that there's that much capital that's flown into it, particularly when heavy launch is way more efficient. Small launch is really just a convenience factor. From the satellite side, what we see here, communications and Earth observation, there's roughly about the same amount of opportunity there. So, depending on what you're excited about, building hardware, you can get involved in both of these. This gray area is really what we were talking about in terms of those emerging industry segments, on orbit activity. Think of like a Made in Space or, a company like Leo Labs. There just aren't a ton of opportunities there to get a job. So I'm going to dig deeper and just show you a geographical representation of where you might have to go to find these jobs. So, here's a handful of these sort of entrepreneurial companies. They tend to be more clustered, around the major tech ecosystem. So you have Seattle, you have San Francisco and LA, you have, Denver, there is some entrepreneurial activity, DC, but, a lot of it is West Coast. And, there aren't a lot of opportunities, scattered throughout the Midwest, or even the East Coast is a little bit harder. When you look at some of the more established companies, there are actually a lot more opportunities scattered throughout the United States. So if you're looking to sort of, not stay in one of the major tech hubs, some of these bigger established players, may provide you more opportunity to look broadly across the United States. It's interesting to see, but, probably, relatively reasonable that, the Denver Metroplex, Colorado Springs, where the U.S. Air Force and a lot of the government activity is sort of headquartered, tends to be where a lot of those companies have jobs. Here I wanted to break down, the different type of sort of roles that are available. So, a lot of the demand for employment, both in the entrepreneurial companies and, the established players, they're looking for, more experienced, talent. So coming in as an associate or sort of an intern, it is going to be quite competitive here. And so you are going to really want to try to differentiate yourself beyond academics, being able to show that you've been involved in clubs, been able to take on some technical work outside of the classroom, have a track record of really pointing to building, building things outside of, the academic work is going to be important to help differentiate yourself. From a business standpoint, if you are more interested here, sales and sort of operations, project management, product management, that's really where a lot of the jobs are. The more support roles, there's just less of them. On the technical side, some people might be surprised, but even the more hardware, the infrastructure companies, software skills are the most in demand. Elon often says that the machines that build the machines are more complicated. And so much of that sort of hardware, software integration is essential to what we're building today. And so the ability to do that type of work is incredibly high demand. And like we said, a lot of the value that's coming off of, space infrastructure is going to be how you interpret that. And so a lot of these roles require, software skills. Systems engineering beyond that, tend to be the next most highly sought after. More so in, the big established incumbent players, which is pretty interesting to see. Less so in the entrepreneurial companies. I don't have a good reason for that. I'm not sure, why. The next thing I wanted to mention was, oftentimes students, ask about building skills in more established companies, and what's the difference between joining one of these big established players and joining maybe a new a startup, or more entrepreneurial company. So the big established players, they have systems in place, they have very defined scopes of work, and they have the resources to be able to pour into you as a new employee to help build your skills. So you're going to be in a highly structured environment that is going to give you not a lot of autonomy, but a lot of sort of support to help build some of your early critical skills that you need to be, an effective engineer or business person, down the road. Our partner, Tom Ingersoll, he helped build and exit Skybox Imaging. He was trained as an engineer, and then worked at McDonnell Douglas on the Delta Clipper program. And that's where he really built his critical skills to become an entrepreneur, and often recommends that as a great sort of foundation. Now, some folks may want, the challenge with that is often you get a pretty nice salary, and so they want to keep you comfortable, they want to keep you in an organization, and keep you happy. The entrepreneurial companies tend to probably not be able to pay you as much, but often give you more autonomy in your work. They're going to let you see a wider variety scope of activities. And oftentimes, depending on where you're at in your career, you can negotiate some sort of equity or options payout. And the combination of that, being in a highly dynamic environment, having to really hustle to sort of solve really complex problems, means it's going to be a really insane, challenging work environment. But if you're successful, and as you see some of these companies that have been successful, the folks that join them early on and help build them, end up, the equity value they create, gives them capital and skills to then become founders of their own. And so, I always find it interesting to see that SpaceX, has generated over 140 new founders. That number has probably doubled since we did this analysis. And what's interesting is the skills that you develop are broadly applicable across many different industries. And so it's not, just space technology. You can go and sort of, do a lot of different work with that skill. So I wanted to translate this historical analysis to helping you right now navigate your job search. We've launched a free platform to help students, and anyone really in their career journey navigate the space technology landscape. And so spacetalent.org, we host jobs from over 550 companies around the world. I think now there's almost 9,300 jobs currently listed. This includes internships, it's very easy to search and find companies. And the reason you should go here, these are not going to be the big established players that I talked about. These are going to be the more entrepreneurial companies that were founded in the last sort of 15 years or more recently, that have raised equity financing and that are, pursuing a more entrepreneurial path. Those are the companies that exist on the platform. And, we make it easy to find those companies if you're focused on infrastructure, if you want to look at companies that are, building on space technology and the applications. So check it out. There's a wealth of information here. It's updated in real time whenever jobs are posted. So it's a continuously available resource. I would mention that we also, if you sign up to be a part of the Talent Network, it takes like 2 minutes, your profile then is going to the top of, we work with a ton of recruiters at these companies. and they come to us because we have a lot of high quality individuals that opt in to this network. It's way easier to navigate than something like a LinkedIn or something like that. And so, a number of top companies, their recruiters look to this network to find great talent. So it could be a way to help build an edge. The other thing I'll mention is, if you want to get involved and start building a product or a company now, we actually make that easy to do on Space Talent. So I mentioned that critical distribution layer, those companies that are making it easy to use software to build on top of the signals that come from space. We curate, I think, 12 different tools, and we have discounts with these providers. We also have cloud credits with Amazon and Microsoft and folks like that to make it easy for students to start working with these signals and see if they can come up with an awesome use case. And if it's something that you're excited about, put together a simple pitch, hack something together and submit a proposal in this open opportunity. We've got over $1.5 million waiting here for a seed investment for great ideas. And we're getting ready to write smaller checks even just to get folks started. So all you need to do is come up with an interesting idea, start building on some of these platforms, reach out to us and let us know if, you have a good idea and, want to try to access some funding. The last thing that I'll mention is we have some additional resources that could actually be helpful in your career journey, no matter what industry you're looking at. So while this career guide is for sort of these entrepreneurial companies, the insights that we get from Deborah Factor and Aaron Zeeb and Shafali Sharma and Kai Marshland, these are just awesome insights for anybody in their career path, from sort of students all the way up to sort of executives. So I'd highly recommend checking that out. Our podcast, we have folks from all over. Lori Garver was on, Michael Sheets was on, Ann Kim from Silicon Valley Bank, Anastasia Volkova from Florasat. So you get the sort of firsthand voice from the entrepreneurs, but also other folks acting in the ecosystem. And then I mentioned, we have this investment quarterly report that comes out. If you want to see who's raising big money each quarter to help, maybe help you navigate your career search, this is a great resource, to follow and keep abreast to what's going on a quarterly basis. So here is my contact information. I ran over a little bit. I'm sorry about that. But please reach out to me if you have questions about, your career trajectory, thinking about an internship, you're curious about venture capital, you want to build, on this space technology and you're looking for some, ways to get started. I'm happy to be a resource and help you in that journey. So I'm going to pause there. That was a lot. I would love to take any questions, if anybody has any.
Yeah, first of all, thank you so much for coming to speak with us. It was a really good presentation. I got questions. So you mentioned in the very, very beginning that now there's a lot of satellite companies launching a lot of stuff, especially with all of the constellations that are currently going up by a bunch of different companies. You're starting to have a lot of stuff pile up there. So is there any regulatory body that's making sure that there isn't too much stuff?
The simple answer is space tends to follow the same legal and policy requirements as the oceans. So maritime law is similar to sort of space law. And the general principle underlying this actually is the same as what regulates the lunar surface as well and any natural resources. Basically, it's first come, first serve. Whoever gets there, it's yours. And if you make it productive, you get to keep it. So, for better or worse, that's the system that we currently have. In terms of self-policing and self-regulating and ensuring that there isn't too much debris, the simple answer is there's sort of a general accepted set of guidelines about, how the industry should behave. There is now, people are generally, you have to launch, you have to have the ability to deorbit your satellite when you launch it now. Like, I don't know if you can really enforce that, but it's generally accepted in a lot of launch requirements. They won't launch your vehicle unless you have the ability to deorbit it. But there's already a lot of stuff up there. And so the biggest challenge with like the environment of low Earth orbit and how we protect it and how we preserve it is really a similar challenge to what we have on Earth around climate change. Like, unless we know the problem and we can actually see it and understand where the problem exists, it's very hard to actually enforce any accountability, right? And so typically the US Air Force had provided space situational awareness as a service broadly available. And so this was a public utility that they provided. The resolution was not great. I can't remember exactly. I think it was maybe like 10 centimeters, 10 meters. But not very high resolution. So you can see large objects on orbit, but what is often the problem is these smaller objects that could create real problems. And so a company called Leo Labs is actually providing much higher precision resolution, and they now provide a data feed to governments, to launch providers, to satellite owners and operators, to insurers, to help you really understand what the risk looks like. And if we don't manage what's going up and how to deorbit it and how to manage it, the cost to put it up there is going to become more expensive because there could be higher risk. The insurance to actually protect your asset on orbit is going to be higher. And so the transparency is helping us price the risk of not regulating this. And so there is some positive momentum in that direction.
Yeah, well, thank you. A very detailed response. I was like, because I've been working on pretty much like for it's something I'm working on. I've been looking at a lot of like satellite data that's open source for now. And like spacetrack.org is a place that has all of this like open source stuff that's published, I think, by the US Air Force, and some other sources. And it really just doesn't seem like from what I've heard as well, it just seems like different governments also have access to different data. So when one company in America announces, oh yes, there's going to be a collision with these two satellites, somebody in China can be like, no, I haven't seen anything in my life regarding these satellites going up anyway, much less them on collision courses. So it really does, and there's that issue, and then also the issue of just satellites going up and then falling immediately back down. I think SpaceX sent up a bunch of Starlink things and then 13 of them fell back down. Yeah. So it seems highly unregulated and very much maritime law-like, except the problem is that things do fall down and crashes do occur. So.
Yeah. I mean, yeah, that is a risk, and you're right. It is unregulated. It's getting better. Transparency is a critical piece of that tool. So definitely check out Leo Labs. I mean, if you're doing research there, maybe email the company, and if you maybe ask them for a sample of their data and see if it's better, or see if it provides additional insight. It is an important issue. It is an environment, like the environment here on Earth, that's really critical for us to be able to manage. And we're just really bad at collaborating or working together at global scale. So, anybody else on the call?
Yes, I also have a question. So if you were to do space entrepreneurship, is America or the United States the best country to live in, or where should the company be started?
I guess, what would you be interested in? Would you be interested in building rockets, or would you be interested in building, software analytics that utilize that information, yeah.
I would. I haven't really thought about that, but I would just okay. I guess if I were to say both, which one would it be for each? I guess if that's too much, yeah.
Yeah, no. So I mean, the best The reason a lot of companies, startups are founded in the United States, even if they operate with outside of the United States, is because the legal structure and the history, the ability to finance and enforce the laws in a known way is very deep, very structured, very known in the United States. And so having a corporate entity that's founded in the United States, that's a Delaware C Corp, makes it easier for you to receive investment and manage your investments as you grow and potentially take a company public. So we've invested in companies all over the world. Simply put, the US law and regulations is probably one of the easiest to navigate. So even a company that we're looking at right now, they're based out of India. Their whole team operates in India, but they've set up a corporate entity to raise all of their capital and manage all of sort of the finances of their business in the United States. So hopefully does that answer your question?
Yes, yeah, it does. Thank you.
All right, I've got a question. First, I also want to echo Jessica's gratitude for you coming and being here today and spending time to talk to us, because all of this is like so fascinating and wonderful. And I was just wondering, sort of when you all were compiling together the numerous opportunities you talked about for space talent, if there were like any interesting patterns or things that you, I guess, discovered while putting together that whole collection of different space opportunities that stood out to you.
I would say, so there are two really, really important areas that are required to start unlocking the value of all of the geospatial, the Earth observation satellites on orbit. And the NGA, the National Geospatial Intelligence Agency, I think it is. So they are the original customer. They're like, the government spies that use satellites for military purposes. They are the biggest user of satellite data in the world. And this is their biggest pain points. And this is the commercial sort of industry's biggest pain points. So first is a lot of people who build satellites and put those sensors on orbit, they want to build the full stack solution. So they want to build the hardware, they want to put it on orbit, they want to process the data and bring it down and clean it up and align it and build sort of a cloud infrastructure. And then they want to build all of the analytics to sell it into like, agriculture and maritime and all of these different industries. That is really, really, really hard to do. And so what you have is a set of government, satellites, and then these private satellites, and they're all siloed. There is no market that you can go to get the picture of, New York City from all of the satellites who have that information. And so access to satellite data is really, really, really hard, and it's kept the market small. So there are companies that are solving this problem. One of the companies we invested in that's probably doing the best job at it is a marketplace called Skywatch. And so they make it possible through an API to bring in, geospatial data through very specific geotags over time from multiple providers, public and private, just through an API. So in a dorm room, you could start, building on top of this data. That's an important step forward. The second problem is around, so this becomes a computer software problem where the images that we're looking at are very dense. It's not like a GPS signal where, you have essentially 4 points of triangulation that are pretty easy to interpret. There's an infinite amount that you could do with the picture. And so you have to train algorithms on this data. And to get high quality training data is, even for the NGA, it's almost impossible to do. Like, training data is like gold. I mean, seriously. That's true for computer vision. That's true for autonomous navigation. That's true for, augmented reality. It's very, very true for Earth observation. And so there are companies that are building synthetic data. It's been used in physics for a long time to be able to train models ahead of us, collecting data in sort of deep space astrophysics. But now we're creating this synthetic data to train our models in a much faster way to unlock the value of geospatial data. So those two things are probably common patterns or gaps that are really, really important to make that big layer of applications that get built on top of satellite data available and accessible and ubiquitous. Any other questions out there? Well, I know it's getting late, so I really appreciate everybody's time. I think I've come and visited, Colombia for the last 2 or 3 years. So I'm really sad that we weren't able to do this in person. I know, it sucks for everybody. But I hope, the school year is going okay, given everything that's going on. And I really appreciate you taking, time out of your evening to, talk a little bit about space companies. Hopefully, you came away with a slightly different perspective around, what this technology has to offer and where there could be some opportunities. And like I said, here's my email. If I can do anything to be helpful, please reach out. It is my passion, my joy to be, helpful and see, brilliant young minds do great things. So please reach out. So thank you very much.
Thank you.
Thank you.
Thank you.
All right. Have a good night.
Bye.